Welcome, everyone. Today, we are stepping back into a world long before power tools, machines, or modern engineering, into a time when human hands shaped stone with a level of accuracy that still amazes us. Around the world, from massive temples to finely fitted walls, ancient stone structures raise a simple but powerful question. How did people, using only basic tools, achieve such extraordinary precision? At first glance, these achievements seem almost impossible. Modern eyes, trained to expect speed and advanced technology, often assume that such results must have required knowledge that has since been lost. But when we look closer, a different story begins to emerge, one that is far more grounded and far more impressive. The precision seen in ancient stonework was not the result of advanced machines or mysterious techniques. Instead, it came from a deep understanding of materials, careful observation, and an extraordinary investment of time. Ancient builders learned how different stones responded to pressure, friction, and abrasion. They experimented, adjusted, and refined their methods over many generations, slowly improving their results. What feels impossible today is largely a reflection of modern expectations. We are used to quick results and automated processes, while ancient craftsmen worked slowly, removing stone grain by grain. Accuracy was not achieved in a single attempt, but through repetition, testing, and correction. Each surface was refined again and again until it met the builder's standard. This perspective changes how we see the past. Rather than imagining forgotten technologies, we begin to recognize the true power behind these structures: human patience, skill, and persistence. As we continue this story, we will explore the tools, methods, and mindset that allowed ancient people to turn simple resources into stonework that still challenges our understanding today. The tools available to ancient stoneworkers were remarkably simple by modern standards. Copper chisels, bronze blades, stone hammers, and later iron implements formed the foundation of their craft. On their own, these materials were often softer than the stone being worked, which makes the results even more surprising. The true effectiveness of these tools did not come from their hardness, but from how intelligently they were used. Rather than cutting stone directly, ancient builders relied on abrasion. Fine sand, crushed quartz, or emery was placed between the tool and the stone surface. When a saw or drill moved back and forth, the abrasive particles slowly wore the stone away. The metal tool acted as a guide, controlling direction and shape, while the abrasive did the actual work. This method allowed craftsmen to shape even extremely hard stone with control and consistency. This process demanded focus and discipline. Each movement had to be steady, each angle carefully maintained. Progress was slow, but predictable. Over time, this repetition produced flat surfaces, straight cuts, and smooth curves that appear precise even by modern standards. Evidence of these techniques can still be seen today in the tool marks preserved on ancient stone blocks. What made these simple tools so effective was the skill of the people using them. Craftsmen spent years mastering a single technique, learning how different stones reacted to pressure and friction. They adjusted their approach based on sound, vibration, and resistance, developing an intuitive understanding of the material. In this context, simplicity became an advantage. With fewer tools, craftsmen developed deeper expertise. Precision was not forced by machines, but earned through experience. The results remind us that advanced outcomes do not always require advanced technology. Sometimes they require mastery, patience, and a deep respect for the material itself. Ancient stoneworking did not rely on cutting in the way we understand it today. Instead of slicing through stone with sharp edges, builders used controlled grinding and erosion. This approach changed the problem entirely. Rather than overpowering the stone, they worked with its physical properties, slowly wearing it down through friction. One of the most important techniques was stone sawing with abrasives. Long metal saws were placed against the stone surface, while sand mixed with water was added into the cut. As the saw moved back and forth, the abrasive particles did the real work, gradually grinding the stone away. This method produced surprisingly straight and even cuts, especially when guided carefully over long periods of time. Drilling followed the same principle. Hollow tube drills, often made of copper, were rotated while abrasive material was fed into the hole. Instead of boring directly through the stone, the drill carved a circular groove, leaving behind a core. Archaeological evidence shows drill marks with consistent spacing, revealing steady motion and controlled pressure rather than force. This method required planning and restraint. Applying too much pressure could damage the tool or ruin the cut. Skilled workers learned to let time do the work, maintaining rhythm and alignment while allowing abrasion to slowly shape the stone. The process rewarded patience with accuracy. Because material was removed gradually, craftsmen could make constant adjustments. If an angle drifted slightly or a surface became uneven, corrections were possible before mistakes became permanent. This flexibility is one reason ancient stonework appears so refined. By replacing speed with control, ancient builders achieved results that still feel precise today. Their methods demonstrate a powerful lesson. Precision does not always come from sharpness or strength, but from understanding how materials behave when given enough time. Accuracy in ancient stonework was not achieved quickly. It was built slowly, through repetition and constant refinement. Instead of aiming for perfection in a single attempt, ancient builders worked in stages, removing very small amounts of material at a time. Each pass brought the stone closer to its final shape, allowing errors to be corrected before they became serious. This gradual approach transformed time into a tool. Working over days, weeks, or even months gave craftsmen the opportunity to check their progress repeatedly. Surfaces were tested, fitted, and adjusted again and again. Stones were often placed temporarily, removed, refined, and returned until the fit met the required standard. What appears today as flawless precision is often the result of countless small corrections. Repetition also trained the hands and eyes of the workers. Performing the same motion thousands of times built consistency and control. Over time, craftsmen developed an instinctive sense of pressure and alignment. This muscle memory allowed them to maintain straight lines and flat surfaces without relying on advanced instruments. Unlike modern construction, where speed is often prioritized, ancient stoneworking rewarded patience. Rushing the process increased the risk of cracks or misalignment. Slow progress, on the other hand, preserved the integrity of the stone and improved accuracy. The willingness to invest time reflects a different mindset, one where durability and precision mattered more than efficiency. This method explains why ancient structures have survived for centuries. Stones shaped carefully and fitted precisely distribute weight evenly and resist movement. Precision was not a single moment of achievement, but a long process of refinement. Through time and repetition, ancient builders turned simple techniques into results that continue to impress and inspire today. Precise stonework depends not only on cutting, but on accurate measurement and alignment. Ancient builders lacked modern devices, yet they developed reliable ways to control angles, levels, and straight lines. Their tools were simple, but their understanding of geometry and balance was highly refined. Strings were among the most important instruments. When pulled tight, a string creates a perfectly straight reference line. By anchoring it between fixed points, craftsmen could check edges, align surfaces, and maintain consistent direction over long distances. This technique was especially useful when shaping blocks meant to fit closely together. Plumb bobs provided vertical accuracy. A weighted string naturally aligns with gravity, allowing builders to create true vertical lines. By comparing stone faces to the plumb line, craftsmen could ensure walls stood upright and corners met cleanly. This principle remains unchanged and is still used in construction today. Flat reference surfaces played a crucial role as well. Straight edges made of wood or stone allowed workers to test flatness by sight and touch. Any unevenness became visible when light passed between the edge and the stone. This method helped refine surfaces until they were uniformly level. Geometry guided the process. Right angles could be formed using simple ratios and repeated measurement rather than fixed tools. By marking points, checking distances, and adjusting incrementally, builders maintained consistency across large structures. Accuracy came from comparison and correction, not from single measurements. These techniques worked because they relied on natural laws: gravity, tension, and symmetry. Ancient craftsmen trusted these constants and built systems around them. Measurement was not an abstract calculation but a physical process, integrated into every stage of work. Through careful alignment and constant checking, simple tools became precise instruments. This approach allowed ancient builders to control complex projects with confidence, proving that reliable measurement does not require advanced technology, only knowledge, consistency, and disciplined practice. Many ancient stones that appear impossibly precise were not shaped that way from the start. Their final appearance was the result of extensive finishing and polishing, a stage that is often overlooked when modern viewers examine ancient structures. This final phase transformed roughly shaped blocks into surfaces that look smooth, flat, and perfectly aligned. After the main shaping was complete, craftsmen refined the stone using progressively finer abrasives. Coarse sand removed visible tool marks, while finer materials smoothed the surface further. This gradual refinement reduced irregularities that would otherwise be noticeable. Over time, edges became sharper, faces flatter, and joints tighter. Polishing also helped hide small imperfections. When light reflects evenly off a smooth surface, seams appear thinner and angles seem more exact. This visual effect can make joints look almost seamless, even when tiny gaps exist. In tightly fitted stonework, polishing was sometimes done after the stones were already in place, allowing craftsmen to blend neighboring blocks together. This process required patience and physical effort. Polishing hard stone by hand could take days or weeks for a single surface. Yet the results justified the time invested. Finished stones resisted weathering better and maintained their appearance for longer periods, increasing the lifespan of the structure. Finishing was not purely decorative. Smooth contact surfaces improved how stones fit together, distributing weight more evenly and reducing stress points. This contributed to the long-term stability of buildings that still stand today. Because modern observers often focus only on the final result, the role of finishing is easy to underestimate. What looks like extraordinary cutting accuracy is often the outcome of careful refinement at the final stage. By treating finishing as an essential part of construction rather than an afterthought, ancient builders elevated their work from functional to enduring, creating stone surfaces that continue to impress across centuries. Ancient stone construction was not the work of untrained labor. It relied on highly specialized craftsmen who dedicated their lives to mastering specific skills. Stone cutting, drilling, polishing, and fitting were often separate roles, each requiring years of practice and experience. This division of labor allowed precision to increase steadily over time. Skills were passed down through generations. Techniques were taught through observation and repetition rather than written manuals. Young apprentices learned by watching masters, copying movements, and gradually understanding how stone responded to different actions. This hands-on education preserved practical knowledge that could not be easily explained in words. Over time, this generational learning created deep expertise. Craftsmen developed an intuitive sense of pressure, alignment, and timing. They could judge progress by sound, vibration, or the feel of resistance through a tool. These subtle cues guided their work and helped maintain consistency across large projects. Because knowledge was shared within small groups, techniques became refined and standardized. Successful methods were repeated, while ineffective ones were abandoned. This natural selection of techniques led to gradual improvement without the need for theoretical science. Precision emerged from experience rather than formal calculation. Specialization also improved quality control. When a craftsman was responsible for a single task, mistakes were easier to identify and correct. Repetition reinforced accuracy, and accountability encouraged higher standards. Each worker understood how their contribution affected the final structure. This system explains why similar construction styles appear consistently across entire regions or time periods. Shared knowledge created recognizable methods and results. The precision seen in ancient stonework reflects not individual brilliance alone, but collective experience accumulated over centuries. By valuing skill, training, and continuity, ancient societies built more than structures. They built traditions of craftsmanship that allowed simple tools to produce enduring precision, proof that expertise, when carefully preserved, can rival even modern technology in its results. The precision of ancient stonework often feels unbelievable because it conflicts with modern expectations. Today, accuracy is usually associated with machines, speed, and automation. When we see tight stone joints or perfectly aligned surfaces made without modern tools, the results seem out of place in their historical context. Modern construction emphasizes efficiency. Power tools remove material quickly, and standardized parts reduce the need for constant adjustment. While this approach saves time, it can also distance builders from direct contact with the material. Ancient craftsmen, by contrast, worked slowly and remained fully engaged with every stage of the process. This difference in mindset changes how precision is achieved. Ancient builders accepted time as a necessary cost. They expected to adjust, correct, and refine repeatedly. Modern builders often aim to get results right the first time, relying on machines to ensure consistency. When ancient methods are judged by modern standards of speed, they appear inefficient, even though they were highly effective. Another reason ancient work feels impossible is the loss of traditional skills. Many of the techniques once considered common knowledge are no longer practiced at scale. Without first-hand experience of these methods, it is easy to underestimate what skilled hands can achieve with simple tools. Cultural expectations also play a role. Ancient societies often built for permanence. Structures were meant to last for generations, not decades. This encouraged careful workmanship and tolerance for long construction timelines. Precision was an investment in durability and legacy. When viewed through a modern lens, ancient stonework seems extraordinary. But when understood within its original context, it becomes a logical outcome of patience, practice, and purpose. The sense of impossibility fades when we recognize that the past operated under different priorities, where time and skill mattered more than speed. One of the most overlooked aspects of ancient stonework is the ability to adjust continuously throughout the process. Ancient builders did not commit to a final shape too early. Instead, they allowed room for correction at every stage, which dramatically reduced the risk of irreversible mistakes. Because stone was removed gradually, craftsmen could respond to what they saw and felt. If a surface began to drift out of alignment, the next pass could correct it. If two stones did not fit perfectly, both could be refined until they matched. This flexibility was essential for achieving tight joints and consistent surfaces across large structures. Test fitting played a critical role. Stones were often placed together temporarily to check contact points. Areas that touched too early were marked and carefully reduced. This process repeated many times until the stones met evenly. What appears as flawless precision today is often the result of countless small refinements rather than a single perfect cut. This approach required restraint. Removing too much material too quickly could not be undone. Skilled craftsmen learned to prioritize control over speed, accepting slow progress in exchange for accuracy. Every adjustment was deliberate, guided by observation rather than force. Small adjustments also improved structural stability. Even contact between stones distributed weight more evenly, reducing stress and movement over time. Precision was not only visual but functional, contributing to the longevity of the structure. Modern viewers often imagine ancient builders aiming for perfection from the start. In reality, precision emerged through a dialogue between the worker and the stone. Each adjustment informed the next step. This process turned potential errors into opportunities for refinement. By embracing correction as part of construction, ancient craftsmen transformed uncertainty into control. Their willingness to work patiently and adapt continuously is a key reason their stonework still appears precise today, even after centuries of wear. Ancient stone precision was not pursued for visual impact alone, it played a critical structural role. Tight joints, flat surfaces, and careful alignment allowed massive stone blocks to work together as unified systems, increasing strength and stability without the need for binding materials. When stones fit closely, weight is distributed evenly across contact surfaces. This reduces pressure points that could lead to cracking or shifting over time. In large constructions, even small gaps can magnify stress. Ancient builders understood this through experience and designed their work to minimize internal weaknesses. Precise fitting also improved resistance to environmental forces. Structures built with well-aligned stones respond better to temperature changes, ground movement, and long-term weathering. Instead of relying on flexibility, ancient builders relied on balance and mass. Each stone supported the next, creating stability through cooperation rather than reinforcement. This approach required foresight. Builders had to consider how stones would behave years or even centuries later. Precision became a form of planning for the future. The goal was not quick completion, but endurance. Many structures were intended to outlast their builders, serving communities across generations. Because of this focus, accuracy was evaluated functionally. A surface was considered complete when it carried weight properly and aligned with surrounding elements. Visual smoothness often followed naturally, but it was not the primary objective. Precision was a means to reliability. Modern observers often separate aesthetics from engineering. Ancient builders did not. For them, beauty emerged from stability and order. A structure that stood firm was considered successful, and its visual harmony reflected its internal balance. Understanding this purpose reshapes how we interpret ancient craftsmanship. The precision we admire today was not excess or decoration. It was a practical response to the challenge of building permanent structures with limited resources. By prioritizing structural integrity, ancient builders achieved accuracy that still performs its role long after its creators are gone. Ancient stoneworking precision did not emerge from written formulas or scientific textbooks. It developed through direct experimentation. Builders learned by doing testing methods, observing results, and refining techniques over time. Every project became an opportunity to improve understanding of materials and processes. When a method worked, it was repeated. When it failed, it was adjusted or abandoned. This practical approach allowed knowledge to evolve naturally. Craftsmen did not need to explain why a technique succeeded. They only needed to know that it did. Over generations, this created reliable systems based on experience rather than abstract theory. Stone itself was the teacher. Different types responded differently to pressure, abrasion, and moisture. By working with many varieties over long periods, craftsmen learned how each behaved. This familiarity allowed them to choose the right approach for each task, increasing precision without formal measurement. Mistakes played an important role. Errors revealed limits: how much force was too much, how fast was too fast. Instead of being hidden, these lessons were absorbed into practice. Knowledge grew from correction, not perfection. Because learning was practical, it was adaptable. Techniques could change based on environment, available materials, or cultural needs. This flexibility helped ancient builders achieve consistent results across different regions and time periods, even without shared written instruction. Modern thinking often separates knowledge from action. Ancient craftsmanship united the two. Understanding came from hands-on engagement, not explanation. Precision was earned through repetition, awareness, and memory stored in skill rather than text. This experimental foundation explains why ancient stonework feels intuitive rather than mechanical. The builders were not following rigid rules. They were responding to real conditions in real time. Through continuous testing and adjustment, they transformed uncertainty into mastery, one stone at a time. When all these elements come together, the mystery of ancient stone precision begins to fade. There was no single secret technique or hidden technology behind the results. Instead, precision emerged from the combination of simple tools, deep experience, patience, and a mindset focused on permanence rather than speed. Ancient builders understood their limitations and worked within them. Rather than forcing stone to behave in unnatural ways, they adapted their methods to suit the material. Time replaced power. Skill replaced automation. Each decision reflected respect for both the stone and the purpose of the structure. What makes this precision feel extraordinary today is how unfamiliar the process has become. Modern construction relies on machines to compress time, often at the cost of direct material awareness. Ancient craftsmanship remains slow, deliberate, and deeply human. Accuracy was achieved not through complexity, but through consistency. This perspective challenges the idea that technological progress always moves in a straight line. In some areas, knowledge was not lost, it was simply replaced by different priorities. The ability to spend years refining a single surface no longer fits modern systems, even though it produced remarkable results. Ancient stonework reminds us of the potential of focused human effort. With enough patience and practice, simple methods can reach levels of precision that rival modern techniques. The structures that still stand today are not anomalies or accidents. They are the natural outcome of a culture that valued skill, continuity, and long-term thinking. In the end, the so-called impossible precision of ancient stonework is not a mystery of the past. It is a reflection of what humans can achieve when time, experience, and intention align. As we reach the end of this journey, one truth becomes clear. The extraordinary precision seen in ancient stonework was not the result of mystery, myth, or forgotten technology. It was the outcome of human dedication, simple tools guided by deep experience, patience, and an understanding of materials built over generations. Stone by stone, adjustment by adjustment, ancient builders proved that time and skill can achieve results that still challenge modern expectations. These structures stand today not just as monuments of the past, but as reminders of what careful craftsmanship and long-term thinking can accomplish. They invite us to look beyond speed and convenience, and to appreciate the power of focus, discipline, and respect for the work itself. Thank you for spending this time exploring the story behind ancient precision. If you found this journey interesting, feel free to continue with us as we uncover more questions that connect human history, knowledge, and imagination. Until next time, take care and see you in the next story.